Okay, so often when you're dealing with sets, you have to deal with intervals, greater than or less than, or here including the endpoints of the set. So we're given this set right here, 1, 2, and 3. It's a set of numbers. So the numbers we need to include are 1 and 2 and 3. And here are the different notations they're giving you. Let's read through each of them. The first one says, notice that there's these parentheses here. That's just holding the group of what we're looking at. And the first thing in all of them you'll notice is the letter x. That's because they're saying x is the variable that represents the numbers in the set. It could be any variable, right? Anything you want. But we have to define what we're going to call that variable. So let's call it x. Then they put this line here, and that means such that. So that all we're saying is you're picking this variable x such that the following are true, right? Or you could say x where x is defined as, and then it gives you the definition. In the first one, they're telling you that x is any number that's what? Well, if you look at this notation, it says x is larger than or equal to 1, right? So x could be a number larger than or equal to 1, but you'll also notice it says x is less than 3. So x is any number that's greater than or equal to 1, but less than 3, and then they define what types of numbers. Well, you can imagine in this range there are all these numbers, but here they're saying where x is an integer. That means what? Well, an integer is a positive or negative whole number. So here you can imagine this number line, right? And the x values can be anything greater than or equal to 1, right? So that would be a full dot, and then you shade it in. All these numbers all the way up to, but not including 3. That's what it's saying here. And not every number between, but just the integers. So that would be 1 and 2, but not 3. So really, all this writing here just tells us x could be equal to 1 or x could be equal to 2. But in fact, this is wrong because our set has 1, 2, and 3. This notation would be right if there was a line under here saying x could be anything less than or equal to 3 because x could be 3 as that's in our set, but that's not correct. Now in this next one, what does it say? It says x is greater than 0 but less than or equal to 3 where x is an integer. So they shift this around a little bit, so let's write that one out. So x such that what? Well, x is greater than 0 but also less than or equal to 3, right? Where x is an integer. Okay. So what is this saying? Well, this is saying, again, x has to be larger than 0. So we have our number line here, right? It can't be equal to 0, so we can put an open dot here, and then shade everything above it all the way up to and including 3, and it can be integers. So in this number range, it can't be a decimal, but an integer. So ask yourself, what integers fall in this range right here? Well, 3 does, because 3 is included. So does 2, and so does 1. So x could be, in this case, 1, 2, or 3. It can't be a half, right? That's not an integer. And it can't be 0 here because 0 is not being included. You can see it right here. X has to be larger than 0, not larger than or equal to. So in fact, this gives us 1, 2, and 3. It must be the answer. You can see how the other ones would also not be the answer. In this case, x is larger than 1 and less than 3, where x is an integer. Well, the only integer that's larger than 1 and less than 3 is the number 2. Here, x is larger than or equal to 0, but less than or equal, and less than or equal to 3. Well, that could be what? Well, it's just like before, the same graph, except 0 is included. So it could be 0, 1, 2, or 3. But 0 is not an element of this set, so that can't be right. All right, hope this helped.